Hello again, and welcome to the second part of troubleshooting garbage collection with Interscope. Now that we know what garbage collection does, what it is and what it does, we learned the different phases, right, of garbage collection, and we also learned that it can be, the Java heap can be divided into different pool memories. So let's go ahead and take a look at Interscope. Let's see the different metrics that Interscope provides with respect to the memory pools and the garbage collectors. So I have a simple ticket exchange application running on the background. I have a JMeter putting load in it. And now, again, if I go back to Visual GC, this is the application. This is a Tomcat application running. And again, so I have my memory pools, right? The perm, the old, and the Eden. And I can see that objects are being created in the Eden, right? Garbage collection is taking place. And those objects that survive are either pushed into my survivor space, right, the S0, S1, or into my 10-year space, the old generation. Let's take a look at Interscope. Let's see what Interscope provides. So again, I have, this is the web application that we're monitoring here on the Visual GC. So we're going to go ahead and look at GC Monitor. And we see right from the start, right, GC Monitor gives us, it's got two folders, memory pools, right, and garbage collectors, right? So it's going to provide statistics about, the containers, the three different containers that it finds, right? And then the performance of the collectors, right? The performance of the process doing, the marking, the sweeping, and the compaction. All right, let's take a look at the memory pool. Let's see what that looks like. We'll open it up. And we see that we find 4 memory pools in this particular JVM, right? In this setup. So you guys should be familiar with them by now. We have the Eden space, okay, a little piece right here. The old generation, the perm generation. Remember, this is where classes definitions are stored, and then the survivor space. Those little 2 spaces. And again, as we mentioned, we're not really interested in the survivor space. Doesn't really tell us much. We're more interested on understanding the size of the Eden and old generation space, and of course the collectors, the performance of the collectors. So let's start with the memory pool, and let's open up, let's say, the perm. We're going to open up perm, and we're going to see what metrics do we want to look at. So what I want to learn regarding the memory pool, I want to know what is its maximum size being set to, and how much memory out of that I'm consuming. So for that, I look at the maximum capacity, and I see that my maximum capacity is about 82 megs or so, right? So then I'm going to look at the amount of space used, right? And I can see that I'm using about 50 something megs, and those again, right? Those are containing my class definitions. Okay, good. Now, and you can see this is not going to go up and down. This is pretty much going to stay steady. Let's take a look at the old generation. So now we're going to open up the old generation. I suppose I can do this. This is better. So from here, I can look again. I can look at my maximum capacity. Right? I can see, and where's my maximum capacity in here? It's right here. So it's about 96 megs. Okay, maximum capacity is about 96 megs. And the amount of space being used, I can see that I've gotten up to 95, and then I garbage collected. Right. So if we go into the maximum capacity, so there's my 96. This is the boundary of this. This memory pool, and then how much memory is being used. Well, we can see that this is really moving fast. So I expect this to go up, and then let's see how this correlates. Right, I'm looking at the old generation. I can see it, my old generation being filled up. Obviously, understand that the Visual GC is performing it's collecting data every 1 second, whereas we're doing it every 15 seconds. But notice there was a garbage collection, right? So I expect to see some garbage collection in here. Let's see what happens. And sure enough, right, there is the garbage collection that we saw in the Visual GC about 15 seconds later. Okay, And then the last one, let's take a look at the Eden space. And again, the Eden space, we're going to do the same thing, right? We want to see what the maximum is, and we see that it's being configured around 24, 25 megs, and these these are the memory being used, consumed. So we're generating objects, right? Without a doubt. As we can see it, in the visually as well, right? You can see how busy the Eden space is. All right, so we understand the sizes of our memory pools, right? And we know how much objects are being created constantly on our memory pool. Now let's take a look at our collectors. Okay, so we're gonna go ahead and take a look at our collectors. So let me close memory. I'm gonna open up the collectors, and I can see that I have two collectors right in this JVM, scavenge and mark and sweep. So the scavenge one is for the Eden space. And again, what is it that I want to know about a collector, a garbage collector? I want to know how often is it, is it performing? Is it, it's kicking in? And how long is it taking to perform its task, right? So how often we're going to look at the invocation per interval, right? And I can see that, it just uses, well, as I loaded, as I ramped my test, you can see that more and more memory is being used, right? As my load test is ramping up, and therefore it's causing the collector to kick in more often, right? I can see that, at this point there were 19 GC invocations. Okay, that's quite a bit. This is not good. And now obviously I can see how long, so this is how many times it kicked in. So it's kicking in very, very often, more than once a second. And now we're going to see, what is the performance. And we can see that obviously it varies and it gets averaged. But, we peak at about, 290 milliseconds, averaging around perhaps 100 milliseconds. Okay. Not too bad, but not good either, because remember, every time that garbage collection kicks in, my whole application gets suspended, right? So what this is telling me, actually, what this is telling me is that every time GC had occurred, my application has been was paused. All right, so this is the one collector. So the other one I want to look at is the mark and sweep. This will be for the old generation. Okay, this works on this memory pool. Again, so I'm going to take a look at the number of per interval count. As suspected, right? I shouldn't get that many, right? I'm always going to get more garbage collection calls in my Eden space, right? That's the whole point of us dividing, the memory pool into these different sections, right? So I can handle, a lot of objects really fast in the Eden space. So I'm being called once in a while, right? And I'm going to look at the performance of this collector. So the performance, every time I'm called, it takes about 278, 285 milliseconds to perform a major GC, right? When collections occurs in the old generation, in the 10-year space, we refer to them as major GCs. When they occur in the Eden space, we talk about a minor GC, and you guys probably heard that we want to use minors instead of majors, right? Because majors we take it takes a longer time to perform than a minor, and hopefully you understand why, right? Because of the phases and so on and so forth, right? The marking, compaction. Hopefully you get that. Okay. Last thing I want to show you, make sure that we're looking at right data, that Interscope is performing right data. I want to show you. So looking at Visual GC, if I were to look at my Eden space, the Eden space doesn't show me how long each GC takes. Doesn't give me that, but it does keep a total count of time. How long GC in general has spent, right? The sum of time that the garbage collector has spent cleaning up the Eden space, and over here it's about 7.6 or something seconds, right? I'm going up. So if I were to go back to my interscope and I look at my collector's total GC time, I would expect to see something similar, right? So this is 7.7, and if I look at this, it's about 7.7. So, right? So this is giving me the same information that the visual GC is, right? Similarly, if I wanted to look at, let's say, from the old generation, the space, or the number of times that it was invoked, it says that we had 5 invocations since we started. Okay, well, we'll go to the total. We go to the collectors for the old generation, and I'm going to look at invocation total count. And sure enough, it shows me that we've done 5 invocations ever since. So this matches the data in Visual GC. Plus, it gives me plus the addition with this is that it breaks down every 15 seconds how long the collectors take, right? The performance-wise. So basically, that's it. These are the metrics that I wanted to make sure that you understood. So now, with that in hand, we can easily understand if GC is causing a problem to our application, right? We're gonna look at the collector performance. We're gonna see how often they're kicking, right? This doesn't look very healthy. So this looks to me, the fact that I have so many GC invocations on my Eden space, that perhaps my Eden space should be expanded a little bit more, right? Given more time to collect objects so that the number of GC cycles are reduced. So I could troubleshoot with that, right? And if I look at my old generation, and if I look at invocations, this is not too bad, right? Because I'm kicking in probably every 3 minutes. Let me see, 149, 150 every 1 minute, actually 1.5 minute. About 250 milliseconds. It's not good either, right? It's not as bad as the Eden space, but again, right? Think about it. My application is being suspended, completely suspended for 250 milliseconds. Every minute and a half, right? So I'm sure my throughput is not doing too well. Okay, now let's take a look at a different JVM configuration. So I have my other server. Okay, I'm running IBM JVM, and if I show you the memory, right? Did you see memory for my IBM JVM? Okay, so I have memory pools, I have collectors. Right, I'm going to go ahead and open my memory pool, and notice that I only have a Java heap. Okay, I don't have the memory pools that I had before, right? Like for instance, when I ran when I'm running my Sun Oracle JVM, right? I had the generation configuration, right? Eden, Alt, and Perm. When I run IBM's, for instance, IBM out of the box configuration doesn't give me this configuration of memory pools. You can see that I have a single Java heap in here. So if I open this up, I'll take a look, and you see I have the same information that I have for a memory pool, but here I only have a single heap space, right? My heap space has not been divided into Eden or Old or anything like that. This is the first one that we covered earlier. Let me see if you guys recall on the first session we looked at this. Remember this? Remember how we go and collect it, and remember what we need to do? This continuous heap. This is what we're looking at right now, right? So again, I'm going to look at my maximum capacity. I see that I'm around 250 megs. Okay, so that's the total size of my heap. Where, right, in that heap, I'm gonna store class definitions, new objects, as well as old objects, right? Long-lived objects. I don't have a distinction. Everything goes into the same bucket. So the other thing I want to look at, we said every time I look at a container, is how much memory am I consuming out of those 250. So if I look, I see that I'm around 67, less than 70 megs. All right. So now let's take a look at the collectors, garbage collectors. So if I open it up, I have Well, sure enough, I have a Mark Sweep and Compact. We should be familiar with this type of collector, and I have a copy, right? So if we'll take a look at the copy one, we'll see how many, we'll look at the invocations. We'll see that it's being invoked a few times, and we'll look at the performance. Every time this guy is invoked, it's spending around 150, 200, peaks, 200 milliseconds to coverage collect. Now, if I look at my Mark and Sweep Compact collector, so this is kicking in very often, right? And let's take a look at the performance, and look at this, right? Look at the performance. It's about 500. Now that's a half a second, right? 600 milliseconds. That's huge. That's a lot of time, right? To coverage collect. So you can see, just at a glance, you can see how efficient, memory is, generation memory is compared to the single continuous heap in terms of performance, right? In this particular case, we noticed that, our major GCs, right, are taking over half a second, and that's just a lot of time. Anyways, I just want to make sure that you understood, in case you run into this where you don't see the different, memory pools. You can have a single, Java heap space, or it could be broken into different memory pools. Okay. I think that's it for us. I'm gonna wrap this up. Hopefully, let me recap some of the major points, right? We talked about the need of GC, obviously. We talked about, the different things, different phases that GC has to go through in order to clean up, right? We talked about the Mark. We talked about the Sweep, right? And we talked about the compaction, right? And then we also talked about, how some JVMs take advantage of Java object heuristics, right? The fact that not all Java objects have the same lifespan, and so we introduced, these different memory pools, right? The Eden space, the old space, and the perm space, and we also introduced the fact that each memory pool has its own collector, right? And the collector is the one that we're interested in seeing its performance, because when the collector kicks in, right, our applications get suspended. So we're very interested to see how often our garbage collection is being invoked and how long it's taking. All right, so lastly, I just want to show you guys the difference that a well-tuned GC makes. This is an example from one of our customers that I worked on when I was on site. And so they were having, obviously, performance problem overall. And this is actually on our MOM, right, on our own APM infrastructure. It was very sluggish. So the first thing that I did when I went on site and started troubleshooting was obviously look at the GC, right? And sure enough, when, this is what I saw, the GC was kicking in, and the collector was taking around 40-something seconds to perform, right? When I looked at the memory pool, I found that the Eden space was just too small. I think they had a total of 2 gigs for the EM, and they had given the default values for the Eden space out of the box, and I think it was 64 megs, and it was just being killed, right? The Eden space was just kicking in, every, a few times a second. And you can see the performance of the collector, how bad it got, right? Obviously, this is being incurred on top of our EM, right? Of our EM response time. So anyway, so what we did is we resized. So we were able to look at, again, looking at the matrix that we looked at, the pool size, right? The memory pools, right? The sizes, how much data is being generated, and then looking at the performance of the collector, we determined that what we needed to do was to expand the Eden space, right? I usually recommend Eden space should be 1/3 of the old gen. So if I have a total of let's say I have 100 megs for my Eden, and and my old generation, I'll probably give around 33 megs to my Eden, and leaving the 2/3 to my old generation. It's a good rule of thumb. You can start off with that, and then tune as you see fit, right? So, anyways, in here, so we made some changes, and you can see as we increase the Eden space, right, a little bit more. This is the 1/3, and then I think I almost made it half. You can see the big difference that it made, right? So all we did in here to gain performance was to tune one of the memory pools, on the JVM, and it bought us that much performance. Anyways, I think that's all I have to say regarding GC. I hope this was helpful to you. Again, my name is Omar Ocampo. If you have any questions, please, you can contact me at omar.ocampo@ca.com. Welcome any questions you guys have, or let me know if there's an interest for any other topic. I'd love to hear from you guys. Thank you so much. Bye-bye.